Hello. In this tutorial, we're going to look at measures of dispersion for discrete data. A measure of dispersion shows how spread out the data is. A larger number shows the data is more spread out, and a smaller number shows the data is less spread out. A measure of spread can also be useful for comparing two sets of data. A very simple measure of spread is the range. This is the difference between the largest and the smallest values. However, it's not a very useful measure of spread as it may use extreme values. Let's look at these two sets of data. Both of these sets of data have a mean of 20. But we can see how different the range is. The first set of data is concentrated around the mean, and the range, the difference between the largest and the smallest, is quite small. In the second set of data, the data is much more spread out. It has a few, both very large and very small values, and so the range will be much larger. So really, the range isn't the most useful measure of spread. Another measure of spread is the interquartile range. Now, when data is written in order, the median, which is also called Q2, is the middle number. 50% of the data values are less than the median. The lower quartile, also called Q1, is the value 1/4 of a way along the data. So 25% or 1/4 of the data will be less than Q1. The upper quartile, Q3, is the value 3/4 of a way along the data. 75% or 3/4 of the data will be less than Q3. The interquartile range is the difference between the upper and the lower quartiles. It's Q3 subtract Q1. Let us look again at those same two data sets. And if I now compare their interquartile ranges, I'll see that the interquartile ranges are very similar. Where the data was very much grouped around the mean, the interquartile range was 4. And with this data more spread out, the interquartile range was 4.75. But we now see that the measure of dispersion used here suggests these two data are more similar. But if we look at this set of data, we see that a lot of the data is grouped around the mean. And both these sets of data have a mean of 20. Based on the IQR, we can see that the two sets of data are more similar in spread or dispersion. Well, that's explained what the interquartile range is. Let's see in this example calculating that value. Jason collected some information about the heights of 19 plants. The information is shown in the stem and leaf diagram. This key tells us that 4/8 means 48 millimetres. We can read this data and see that we had a plant of 11 millimetres, 12 millimetres, 13 millimetres, and so on. And we can see that this data is already ordered for us. Now here we need to see the value of n. The value of n is our number of data points, and here n is 19. And then to find the position of our median, we will do n plus 1 divided by 2. In this case, that's 19 plus 1, which is 20, divided by 2, and that will let me know that the median is the 10th value. So the median here, the 10th value, let me count along, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th value here is that 0. Remember, it's not 0, it's 30. So I'll write the median. Now, we've also learnt that that is called Q2, and that value is 30 in this case. So let's find our Q1, the first quartile. Again, we're going to do n plus 1, but this time we want a quarter of our data. So we're going to divide by 4. In this case, 19 plus 1 is 20, divided by 4. That's a nice round number, it's 5. We're looking for the 5th number. Counting along, 1, 2, 3, 4, 5. I can see that Q1, my first quartile, is 23. So finally, I'm going to find the upper quartile, or Q3. Again, I'll do n plus 1. Now I need 3/4 of a way along that data. So I'm going to divide by 4, multiply by 3 to give me 3/4. So that's 20 divided by 4. I need that 3 times for 3/4. That will actually give me the 5. 20 divided by 4 is 5, times 3 is 15. I'm looking for the 15th value. Counting along, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 37. So Q3, my upper quartile, is 37. So the interquartile range, shortened to IQR, will be the difference between those two values. It is Q3 minus Q1. In this case, 37 minus 23, which is 14. Now in this case, the numbers worked out very nicely. I need the 10th, the 5th and the 15th numbers. And we were fortunate that we had 19 plants, giving us 20 divided by 2, etc. The numbers aren't always quite so nice. Let's have a look at another example. In this case, I've just added one more plant to my stem and leaf diagram. So Jason collected some information about the heights of 20 plants this time, and this information is shown in the stem and leaf diagram. So to find the measures, I'm going to proceed in the same way. So for the median, I'm going to do n plus 1 divided by 2. Remember, this time my n is 20. I had 20 plants. So that will be 21 divided by 2, and that will be 10.5. So I need to go along and find the 10.5th value. Well, of course, that doesn't exist. But remember, this is the 10th value, and this will be the 11th value. So I need to find the value in between those two. So it will be 30 plus 32 divided by 2. That's 62 divided by 2, which gives me 31. That's my median value. It's also called Q2. Now, you might have been able to see that 31 was between 30 and 32, but that shows you again, if the numbers aren't quite so nice, then add them together and divide by 2. So for my first quartile, I'm going to add 1 to n, and I need a quarter of my data, so divide by 4. 21 divided by 4 gives me 5.25. Now that's the position of my first quartile. 1, 2, 3, 4, 5. That's the 5th value. And I need to go along to the 6th value. Now here, I'm quite fortunate that they're both the same, because the 5.25th value in between those will also be 23. So that's quite easy. Q1 will be 23. Moving along then to Q3, my upper quartile. Again, n plus 1 divided by 4 give me quarters, and I need 3/4 of the way along. 21 divided by 4, and that needs to be multiplied by 3 to give me the 3/4. So that is 15.75. I need to go along and find the 15.75th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's my 15th value. And that's my 16th value. The 15th value is 37. The 16th value is 41. Now I need to go 3/4 of the way along between those two values. Now, if I think of a number line, that means that I'm working 37, 38, 39, 40, 41. So I need to go 3/4 away along that gap. Now I'm quite fortunate again because I've actually got quarters here. Each of those steps, there's 1, 2, 3, 4 steps. So each of those steps is a quarter. So 3/4 of the way along would be here. So my Q3 is 40. Now, that's okay in this case, I can have a look, but what if it wasn't quite such a nice gap? Well, I could see that I needed to do the difference between the two, 41 minus 37, which gave me 4. I needed to take 3/4 of 4. That would give me 3. And that needs to be added on from that 37. 37 add on the 3 would give me 40. So that's a way you could calculate that value if it wasn't quite such nice numbers. So we were here to find the interquartile range, which is Q3 minus Q1. In this case, it is 40 minus 23, 17. That's the end of this video. I hope you found it useful.